we present our paper. Don't they really hear us? Designing private conversations in social virtual reality. Virtual reality is changing how we interact socially, but how private are our conversations? Imagine you're in a crowded virtual environment, trying to have a confidential discussion. Unlike real-world interactions where you can lower your voice or step aside, social VR lacks intuitive mechanisms for seamless private conversations. Today, we explore our research on designing a more intuitive and secure space for private conversations in social VR. We'll cover the challenges, findings from our user study, and a novel design space that helps address these concerns. Social VR applications allow people to engage in shared virtual spaces through avatars, enhancing a sense of presence. However, transitioning between public and private conversations isn't seamless. Current solutions, like menu-based breakouts or direct messaging, disrupt immersion and don't feel natural. More importantly, users hesitate to have private conversations in VR due to concerns about security, usability, and the fear of being overheard or recorded. To address these issues, we conducted 2 studies, expert interviews, and a controlled user experiment with a social VR prototype. In the expert interviews, we covered user psychology and user experience, as well as privacy and VR security. In the controlled user experiment, we had 12 participants trying existing methods of social VR private conversation, such as a phone call-like interaction, and leaving for a private room, as well as co-designed alternative methods. Our analysis of both studies uncovered several key themes that shape how users experience private conversations in social VR. One of the most prominent concerns was background noise management. Users wanted better control over environmental sounds, allowing them to focus on their conversations without being distracted by ambient noise or overlapping voices. Some participants preferred absolute silence, while others desired a balance, reducing interference while maintaining some level of social presence. This ties directly into the second theme, isolation preferences. While some users felt safer and more comfortable in completely private rooms, others wanted to remain visually present in the shared space but be inaudible to outsiders. The ability to control one's level of isolation became a crucial aspect of feeling secure in VR conversations. Another critical issue was the lack of clear privacy indicators. Users often felt uncertain about whether their conversations were truly private. Without explicit cues confirming that others couldn't overhear them, they hesitated to speak openly. Some suggested subtle visual or audio signals that could reassure them that their discussion was protected. Interaction methods also played a major role. Many users disliked rigid, menu-driven privacy options and instead preferred natural, intuitive gestures. They wanted to initiate private conversations the way they would in real life, by whispering, turning away slightly, or making direct eye contact, rather than clicking through menus or teleporting to isolated spaces. Context sensitivity emerged as another important factor. Users felt that private conversation settings should blend naturally into their environment, rather than feeling artificial or disconnected. Jumping into a separate, sterile space disrupted the flow of interaction. Instead, they suggested private spaces should resemble the surrounding world, making the transition feel more seamless. Finally, trust and security concerns were a significant barrier. Many users worried about data recording and potential eavesdropping, which made them reluctant to engage in private conversations at all. Without confidence that their words wouldn't be stored or misused, they hesitated to share personal or sensitive information in VR. From these findings of both studies, we constructed a design space that categorizes different approaches to private conversations in VR, considering 4 key dimensions. The first is modality, which defines how users initiate privacy. This can include gestures, user interface elements, spatial movement, or auditory cues. A natural and intuitive modality can make private conversations feel seamless rather than forced or artificial. Next is availability, which determines how visible or concealed a private conversation is to others. Some conversations may be entirely hidden, while others may be noticeable but not audible or even fully open depending on the context. The third dimension, awareness, focuses on user control and transparency. This includes permission systems, consent mechanisms, and clear privacy indicators to ensure users know when their conversations are private and who has access. Finally, isolation describes the level of separation from the surrounding environment. This can range from fully enclosed private spaces, where users are visually and audibly cut off from the public area, to more subtle audio masking techniques that preserve presence while ensuring privacy. Our research highlights the need for more natural, secure, and context-aware private conversation methods in social VR. Current designs fail to match human expectations for seamless, confidential discussions. Our proposed design space lays the foundation for future VR applications to implement more intuitive solutions. Looking ahead, several areas of development can further enhance private conversations in VR. One key direction is implementing automatic artificial intelligence-driven privacy indicators, which dynamically adapt to user behavior and provide subtle yet effective signals for privacy status. Another exciting possibility is experimenting with gesture-based activation for private modes, allowing users to transition seamlessly into a private conversation using familiar real-world gestures. Finally, exploring trust-enhancing transparency about data privacy in VR can help users feel more confident that their conversations remain truly private, fostering deeper engagement and self-disclosure. By addressing these gaps, we can create VR environments that truly feel as natural and secure as face-to-face interactions. Read the paper for more information.